students, this is the rest class with Professor Lee, and I will give some information on the regression. Then, well, usually I have writing day for students, as I already talked to you this time. You can whine. You can complain. All right. Okay. Well, we have talked about the rate approach to get the kinetic wave constant. Okay, KW. At batch case, you have one record, and you can measure the concentration with respect to time, and you can have RA, right? But for the continuous system, for the proper record, you have very different record with different size, so that you can have different theta. So you can check the concentration of a certain contaminants with respect to theta. So you can also have rate here. The rate is a little bit different here. Well, just like this. Okay. The important thing is, by the way, our basic assumption is direction A goes to B, right? So here, let's say the RA rate is K times CAN power. Well, K is also important, right? But what about N? The order of direction also important, right? Most of the engineers, we usually assume N as a 1. Why? Why do you want that? Although we are the gods, the son of gods, the king of mathematics, actually, right? Engineers. Well, although this N explained as partial differential equation, engineers can solve the problem. Why do we want to assume N as a 1? That is very, naive, assumption. Well, that could be, though. Any idea on this? 혹은 그나 얘야. Any idea on my question? You didn't hear, right? Okay, I understand that. 선정이. Reference smile is not the answer. Think about this. What is our final efforts? What do we want to do as an environmental engineer and consultant? We want to solve the client's problem, right? So, whatever it is, what cost it would be, we want to degrade the contaminants. So, well, although you don't have any solution, but in front of the client, you need to talk to client. I can do that. And the degradation efficiency is 100%. you cannot, well, your boss actually fire you. This is very, very important thing, right? So, one thing, if you want to, let's say, this water is contaminated with creosote, very toxic, organic contaminants. We want to degrade this creosote. Creosote is very fragile with the oxidants, so we can add oxidant just like H2O2, and we can add hydroxyl radical, or we can add ozone here, so that this can be degraded, right? So what kind of work do you want to do to fully degrade this creosote? Think about that. Who's beginning when they fight? Over, let's see. I mean, if you have many people, you can win the fight, actually, right? Although that is very ancient word tactic. Sometimes that works in nowadays problem. So what we want to do is we want to add more and more reactants to fully degrade this one, right? So well, think about that. This is very simplified, solution. Well, if you just add 1 milligram of H2O2, you have 20% degradation. What do you want to do? Just increase, the amount of the H2O2, right? So 10 times more, you can have 50%, or 100 times more, you can get more, right? So you want to increase what? The concentration of reactant, so that you can get full degradation, so that your boss can, give you bonus, actually, right? So here, the rate equation, let's say dc over dt A equals kc. Well, there is creosote, let's say this is Ca, and reactant Cv, just like this, right? But if you think the Cv concentration, reactant concentration is so high, this is kind of, considered as constant. So you can put it as K prime Ca, right? So this is the reason why all the engineer and environmental consultant assume pseudo first or first order reaction, because the reactant can be added, tons of amount, so that you guys can get the full degradation, right? All right. Then, so let's think about this. But we are the engineer. We want to know the reality of the number of order. So how can you get it? This is kind of very simple. So you can get some experiment and put the log A in CA, and then you can get Okay. Also, we can have window here. If you don't want to do this, or if you did it well, the numerical way, let's say log array. Well, you may have some, experimental data, which is real value, but you can actually get some, predicted value. Right. But there will always be some kind of differences you just this amount difference 1, 2, different 3, difference 4. So you guys actually can have, well, let's say this is just a y equals a0 plus a1x. This is a predicted, actually value. So we just want to make some differences between the real value and the predicted value. So the real value actually is RAI, and the predicted value is KCA, actually I. N, right? And this is the difference between these two actually values. And then we just make it second power, and then just add all differences, and then find out N and K value to make some of list square. So this is kind of list square. So the sum of list square. So just to find out n and k value to make the sum of list square. Minimum. If this is 0, what does that mean? That means there is no difference between these two, values. So it is actually on the right. So you guys can run this one, and how you can solve this least square problem. If you just check the Excel has very wonderful tool named Solver. Solver actually kind of very simple, least square evaluation tool. If you just assign the x and y data file, and if you just put some this equation at the cell, we call it target cell, and then you give initial guess 1 or 2, anything, it actually calculates the risk scale of this equation. So you can have N and K. Simple, is it? Wow. This is very basic of the numerical method. Wow. That is unexpected kind of response from the clear. And but important thing is, now this is kind of very simple defined problem, and I just give you one example. But think about that. As an environmental engineer, what you can do at the graduate school is, it is just like this. The environmental engineer want to predict the concentration differences, the concentration with respect to time and with respect to space. I mean, think about this. This is a kind of very big field, and let's say there is very big facility to prepare nuclear warhead. You guys know what nuclear warhead is, right? That is kind of atomic bomb or hydrogen bomb. Because if you want to purify those material radiochemicals, you really need to purify the chemicals very well. That is very, very important. So that you just remove unexpected and not necessary impurities, so that it can kill many people. They did it at in the middle of desert in the United States, named Los Alamos. And this was actually located. There is another place, Sandia. These were actually codified name when the Manhattan Project prepared. But nowadays these are the name of the national laboratories of the United States. There is one more thing, Pentax. So to purify those radionuclides, they need to conduct some purification step. It will take long time, and it will take humongous ton of the chemicals, acids, or even the organic chemicals. So if you check those facilities, they really have very good storage for organic chemical contaminants, inorganic chemical contaminants, even radionuclides in there. Well, around the 1940, 1950, now people really have very strong interest in the contamination of soil and groundwater. But nowadays, they became to know. They just the simple remediation technique is just dig the hole, so make very big pond, and just pour some chemical and put the clay liner on the surface, and then pour all sorts of chemicals, contaminants. Well, just don't make that face, but this is the real. This was the real, actually. So this, found actually, all the chemicals can break down, and if there's groundwater from marching, the chemicals actually spread out. So most of the groundwater sources easily contaminated. 1970s, 80s. So this is the reason why the United States, pay tons of money for cleaning this soil and groundwater. And most of the United States state usually use this groundwater as their drinking water resource, actually. So drinking water can be obtained from the groundwater. So the groundwater is fully, heavily, contaminated. So they want to clean this contaminated soil and this contaminated groundwater. So billions, trillions tons of money actually, pour in this. But the important thing is, compared to the gas, contaminated air, contaminated water, contaminated soil and groundwater, you cannot easily, heal because you cannot see that. You can see contaminated air and you can see contaminated water, actually, isn't it? You can see that. But how do you know the soil is fully contaminated or the groundwater is fully contaminated? Before drinking and before having carcinoma, you never ever know those groundwater contaminated, actually. So what the environmental engineer is doing is, they just want to know, well, there is a big source of contaminants. They want to know the concentration distribution in this field. Let's say this is 100 kilometer long, and this is 10 kilometer long, and this is, let's say, 200 meter depths. They really want to know the concentration distribution at this space, and they want to know the concentration differences with respect to time, and then they also want to know after doing some environmental technology how the contaminants can be treated. They want to know, although they cannot see it. So how do you show the contaminant, change, degradation? Even you cannot see that. Using this numerical method actually can give you the concept of the and solution of the concentration difference. Well, I cannot show everything here, but if you really have a very strong interest in this, numerical modeling and the design, well, you can get it at the grade school. This is kind of a very wonderful, thing you can do as an environmental engineer. You can say, the mathematics rules everything at this moment, I think. Okay. There is a couple more about the irrigation part, but I don't want to give you further. Have you heard about the Newton-Raphson method before? It is one of the numerical. Nope. This is curious, the best one. Let's do some more. And the another approach is, well, for this risk scale method, this could be linear, or sometimes this could be non-linear equations. So if you are using non-linear form, you really need to be very, very careful. The first guess is very, very important. If you don't have a very good first assumption, well, you cannot have, actual parameter estimation. This is very, very important. Well, this is just like the so we actually want to know these 2 points, right? So what the Richter scale and Newton-Raphson method tells you is the initial guess, and it just bounce back like this, and it just find out the smallest points which can make the Richter scale meaningful actually. But if you take this point, it cannot actually jump up. So it just bounce back here, around here like this. So you cannot get the exact value here. So when I was undergraduate school, to having this estimation value, it usually take 30 minutes actually. But nowadays, the development of computer, well, although you start with this point, if you're using supercomputer or very good computer, well, actually you can take these points. That means computer development actually spoil you guys. Yeah, that is very important thing. Well, I think there is a couple more regression in the numerical analysis, things I can talk to you, but I just want to stop here because I just want to hear, as I already taught, you guys can whine. In Korean proverb, if we put the kings in a place, they never ever complain. Anybody, but please be a king and give me complaint. Do I need to start, or do you want to be assigned by me, or no? One more thing for the homework. Well, I really have very difficulty for the reaction director design because the part I have taught to you is mostly from the advanced, environmental chemistry. So if I just put the same homework I used to give to graduate student, the problem is kind of very, very difficult to you. So, but if I don't give you any homework sets, I really don't know. Well, Adhika may be very happy, but that also spoils you. Yeah. So I will just give a couple of problems, so that you guys can design the blood flow reactor and CFSTR. All right, couple of 3 problems. Anyway, I'm very sorry about that for the rate upload of the homework. And one more thing I need to say is, do you have consensus on the schedule of final exam? No?
No.
How about the Wednesday, 11 o'clock?
Wednesday 11 o'clock.
Here.
저 수요일 저녁에 파이널 발표가 있어서 시험 대신하는.
But it was Wednesday night. I'm talking about 11 a.m., not 11 p.m.
전 유체역학이 11시에 끝나서요. 조금만 뭐 1시간이라도 이렇게 늦게 들으면 안 될까요?
Does that mean the exam
네, 그
ends?
전에 시험.
So the exam can get started at
12?
11:50.
Wow. This guy really, you understand Korean, right?
I just get what you want to say because I'm listening.
How much time do you need? So,
그냥
1시간. 1 hour, 2 hour after
maybe
having
I need a
lunch?
little bit break between 2 exams though.
Okay. I think I'm just to finish the final exam quickly and enjoy, go out and have party. Tuesday, 9 a.m. Michael doesn't agree with that. All right, Wednesday is not good. Tuesday,
No.
Wednesday,
Monday.
Monday,
Monday.
perfect. Monday, 11 o'clock. 11.
네.
Okay. But this, question.
I have another exam at that time on Monday.
If so, you can have exam by yourself. With
Oh, really?
9 a.m.
you have the same.
No, I don't
Right.
on Monday.
아니면 아예 수요일 시험을 한 1시쯤에 시작하면 어떨까요?
1 o'clock. This at 1 o'clock Wednesday.
Yeah.
I mean 1 p.m., not 1 a.m. All right. Talk to people. 1 a.m. Wednesday. No, 1 p.m. Wednesday. What date is it? Is it May 26th?
No,
Oh.
저도 사실 시험.
월요일
All right. If so, let's have it at 7 p.m. 8 p.m.
7 p.m.
12시에 하면 안 돼요? 그냥 그럼 11시에 교수님 해요.
She said 11 o'clock is okay.
11.
아니 11시 반부터 1시까지 하면 어떨까요?
All right. 11:30. Wednesday. 11:30 a.m. May. What was that? May
23rd.
23rd. All right.
1 hour?
I think I will give 1.5 hour exam. You can have more if you want.
How many questions will be?
Maybe 6, 7. With the sub problems.
And we will from the beginning of chapter 1 to 5.
Pardon me?
The material which we took in.
Oh yeah. Well, as I already talked, it covers whole, but as I already talked, 30% from the previous one, 70%, new one. So reactor, as I already talked, reactor is very, very important, right? So you could be, the gods or the king of the reactor. You should be that. And next week, my PhD student, Daesung, will give you lectures on the water and wastewater treatment technology. So he will introduce you the basic part of the water contamination and its treatment. All right, 3 hours. Okay, so 11:30 a.m. May 23rd. Okay. All right. Is there anybody who really have difficulties, with me in this class? Well, we have just 10 minutes, I think. 20 minutes. 10 minutes, anyway. No? Yeah, Tom, you can start. You can say, you suck, Professor. I can accept that.
I find
Just at this moment.
video clip.
Huh? Video
Why
clip.
couldn't I find video clip?
All these. What video clip you know?
Video clip of lecture.
Yeah.
Yes, I couldn't find video clip from the lecture after 16 April.
Oh, really?
16 April is the last.
Okay, I will talk to my research assistant to upload it. All right. You can find that at the homepage, or you can directly ask research assistants. They will provide you the video clip. But you are not going to use it as a that purpose, right? It is, copyright materials. All right. Anything else you want to ask? Or let's start the whining session.
I had a problem.
Problem with?
Because we don't have any book, so I had to write down your lecture. So I have to write down and I have to hard, so it was a little fast to me.
Oh, it was faster. Okay. So what about the environmental science section? Was it easy?
Yes, just listening is okay, so it was okay.
Well, yeah, okay, I will take that. But the purpose of this course is, the first time, I just don't want to give the environmental engineering part, actually, just to focus on the environmental science part. And I really, when all of you have A from this class, I really did that. So the purpose of this course is you guys can say, wow, environmental science is very, very easy. And easy concepts can be applied to solve the difficult environmental problems. If you can, feel that, or if you can, know that, well, you really have the goals you achieve, actually. So, for the environmental engineering part, well, I'm really sorry about at first time I really want to use the book I assigned. I can find though that book is not that good, but I'm not saying. Somebody can say, Professor, I purchased it. So, that guy purchased one, but I think that is good for you. It can be used as, a Bible for you, But I think the time is not, much to cover materials in that book. So I decided to teach the rector engineering things, because that is kind of the very basic of environmental engineering. And also wastewater and water treatment is kind of very basic of environmental, engineering. So you can have it, and also for the faster, lecture. Well, I will, slow down later for your, other students next time. Okay. Next semester. Because this is required course for the civil and environmental engineer. I don't believe someone can have, but if someone have it, well, you can see me. Any other complaint? Hangul is kind of character, not verbal language. So I really don't know if you say Hangul, your question, how can I understand it? But you can speak in Korean. 한국말로.
숙제 문제들이 전체적으로 시간을 많이 해서 많이 풀어야 되는 거였는데 그 문제 규모가 좀 미묘하게 많아서 언제나 좀 늦었던 것 같습니다. 그게 한 15문제에서 20문제 정도가 적당하다고 생각하는데 언제나 27문제가 나와서 7문제 여치가 뒤로 밀리는 현상이 처음에는 괜찮은데 이제 뒤로 가서 문제가 어려워지니까 점점 시간이 더 필요하게 돼서 그렇게
his complaint was the number of questions are too many.
Slightly many.
And anyway, slightly many. So he really has difficulty solving the problem on time. Well, I know that. I know that very well. I taught, 2 years at the Indiana University, just like sophomore, like you. Stupid American students there. They are really stupid, actually. So, stupid guys. Well, anyway, they really had hard time. The half of students cannot, solve the problem, actually. So I worried, very much the future of the United States at that time. Well, fortunately, you guys really did and are doing wonderful thing, wonderful job right now. I know that the problems are very, very difficult. Even you don't know how to apply it. But important thing is, using the very basic and easy concept, you can actually try to solve the problem, environmental problem, which is very, very important. That is my goal. If you just tried it, well, as I already talked to you, you already achieved it, right? And I know that, so I'm not gonna give, heavy penalties on late, submission. So please submit. That is very, very important. And never ever, copy. That is shame, actually. Right? You guys can discuss each other and discuss and then separate, right? And do the work. Got that? And as he said, I really count on the difficulties. The important thing is, hey, you focus on me. My God, he just asked me, and then he didn't. 그러면 안 되지. 야, 인간적으로 그러면 안 되지. 그렇지 않겠니? 물어보고 난 다음에 딴짓해. 그건 아니다. Anyway, I'm not going to give heavy penalties. Well, there should be kind of 1 point or 0.5 points difference, actually. But submit. That is very, very important. And also a little bit, penalties on the very late submission. If you submit, number 1 or number 2, well, there should be some penalties, right? Anything else? Tom?
I think it's better if we can have some notes on page regarding this environmental engineering part.
Okay.
Because maybe sometimes you can miss some part. Especially me. Actually, I'm not good at chemistry, so I'm not really understand on lecture time, so I need to read some part again.
Okay. Well, as I already talked, the record part is kind of a little bit difficult because, as I already talked, that is grade school material. I never ever, prepare the PPT file for class. Actually, my lecture style is just writing, solving the problem. That is what I have done so far, actually. So a student, actually teacher, professor writes on white or blackboard, and student actually, prepare the lecture note. That's what but I think the PPT file for the environmental science part kind of very effective, I think. And also, I really don't know the video clips really help or not. But if you miss my request, well, you can check it. Actually, you can have it. That is also important thing. But I am a little bit against your view. Prepare the lecture note and put it at the my homepage. I don't think so. Well, my lecture, my English is not perfect. You sometimes cannot understand what I'm talking. But the important thing is preview is very, very important. Although I actually didn't give you any information what part you need to preview. But if you are previewing the materials, that could be very, very helpful. And then if you can prepare your coursework note, well, later, just think about that. You are a professor. You just get back to your country, and you need to teach. At that time, the well-prepared note is very good material for teaching, I think. So, I can support you PPT file, but writing yourself is very, very important to me as a teacher, as a researcher. So, right. Anything else? For you, do you still believe you are doing the right thing? Okay. 내 생각은 말이야, 이게 뭐 본인만 그런 게 아니라 다들 그래. 이게 이렇게 이야기했음에도 불구하고 다들 들고 와서 이제 그걸 하는데, 근데 이제 내 생각은 전에도 얘기했지만은 본인들이 본인 나름의 자존감을 가지고 이렇게 이걸 지켜나가야지만이 이 클래스가 이제 붕괴되지 않는다라는 게 내 생각이야. 고등학교 이미 학교 클래스가 붕괴됐잖아요, 그렇죠? 그래서 다 자제는 않게 해야죠. 내가 선생이니까 이제 그런 말을 하는 건 아니지만, 만약에 얘기하는 사람의 대부분은 아마 강단에 서게 될 사람들이 대부분일 것 같다는 게 내 생각이기 때문에, 그리고 또 그게 좋았기 때문에 정말 공부 엄청나게 해가지고 이렇게 들어왔고, 근데 만약에 여러분들이 선생할 때쯤 돼가지고 정말 애들이 막 그렇게 한다, 그거는 좀 아니라고요. 그리고 또 이게 혹시 우리나라만 가지고 있는 그 잘못된 생각일까? 나도 한 2년, 3년 정도 미국에서 가르쳐봤지만 정말로 내가 나를 갖다가 리스펙트한 친구들, 그리고 또 만약에 이제 그 과목을 들으러 정말 좋아서 들으러 온 사람들 같은 경우는 절대 따지지 않는다. 이게 서로 간의 상호 리스펙트라고 난 생각을 갖다 해요. 이게. 그래서 만약에 이 코스가 예를 들어가지고 들을 필요가 없고 재미가 없고 나한테 도움이 안 된다면 학생 여러분들은 안 들어야 됩니다. 그렇지 않아요? 왜 들어와요? 이거 전혀 나한테 도움도 안 되는데. 점수 따라. 그렇다고 뭐 점수가 그렇게 이게 물론 뭐 다 A 받았으면 좋겠지만. 그래서 다음부터는 여러분 좀 그랬으면 하는 바람입니다. 그러니까 만약에 정말 자기가 신뢰를 갖다 할 것 같으면은 그 수업을 갖다가 들어 안 와도 돼요. 그죠? 그러니까 그러고 만약에 그러니까 정말 들어야겠다 싶으면은 준비를 갖다가 해가지고 오는 겁니다. 그러니까 프리뷰? 나는 한 가지 내가 더 이야기를 하면 영어 강의하는 게 어렵죠, 여러분. 근데 한국말로 내가 이렇게 강의를 해도 나중에 시험 보면 똑같은 시험 결과가 나와요. 영어 때문에 그럴까? 그건 절대 아니거든요. 그러니까 정말로 자기가 이 수업이 도움이 된다거나 아니면 이게 그거라고 생각이 되면은 프리뷰를 하게 됩니다. 아니면 리뷰를 하든지. 그러니까 두 개 중에 하나를 갖다 하더라도 여러분들한테서는 분명히 도움이 되려는 그렇기 때문에 앞으로 그러니까 대학교 교수까지 만약에 이렇게 붕괴된다 그런 말이잖아요. 나는 대학교 이렇게 프로페서 안 하고 걔 누구야 이수만 또 이수만하고 비슷한 일을 하는 사람 또 누구니? 응? 누구지? 연예기획사 사장 그거 할래? 그거 하면 모든 애들이 전부 다 이렇게 그치? 바람을 쳐다만 보고 있잖아 이렇게 훅 하면서 그런 사람들한테 있어서 그쪽에 있는 사람은 신인데 적어도 선생은 그러니까 여러분한테 신은 아니더라도 여러분들의 그러니까 좀 이렇게 앞잡이인 줄 모르고 길잡이 노릇을 갖다가 앞잡이의 길잡이 길잡이 노릇을 해줄 수 있는 그런 캡틴이 됐으면 좋겠는데 그 캡틴을 여러분들이 흔들면 안 되죠, 속에서. 그러지 말기를 바랍니다. 알겠어요? 그리고 쏘리란 말은 참 그러니까 thank하고 쏘리는 굉장히 그러니까 하기 쉬운 말이죠. 그죠? 그러니까 많이들 하세요. 자기가 신뢰했으면 쏘리라고 얘기를 하고 고마우면 thank라고 얘기를 하고 그럼 모든 일이 다 잘 끝나는 거예요. 미안해서 특히 카이스트 학생들이 못하는 것 중에 하나가 뭐냐면 인사를 잘 못해요. 왜냐하면 이때까지 그냥 공부는 해왔기 때문에 이해하거든. 근데 중요한 건 뭐냐면 내가 대학원생들한테 딱 한마디 하는 게 있어요. 너희들이 만약에 이 지구 상황에 있는 사람들의 3분의 1을 갖다 먹여 살릴 수 있다고 생각을 갖다 만약에 한다면 개차반으로 살아도 좋다 이거죠. 왜냐하면 그 사람은 같이 있습니다. 왜? 3분의 2 먹여 살릴 거기 때문에. 하지만 그냥 본인이 생각해서 어느 정도 스마트하다고 생각이 된다면은 같이 더불어 살아야 돼요. 응? 절대 잊지 말기 바랍니다. 자기 생각에 정말로 자기가 뛰어나다. 그러니까 노벨상 그 이상을 갖다 자기가 할 수 있다. 마음대로 하세요. 그래도 모든 사람이 리스펙트를 할 테니까. 릭스 몰리라는 사람이 있습니다. 그러니까 내가 이제 존경하려고 했다가 너무 인간성이 아니라서 이제 좀 이렇게 멀리 했는데 멀리 하냐 그 사람은 난 잘 알지도 못하죠. 근데 릭스 몰리가 3년 전에 죽었어요. 그러니까 Father of Nanotechnology라고 불리는 사람이에요. 라이스 유니버시티 교수, 화학과 교수이고 근데 이 사람이 이제 결혼을 했다가 7번 했어요. 7번 했는데 굉장히 좀 이렇게 문제가 많았던 화학자인데도 불구하고 그의 이제 지구를 먹여 살릴 만한 그런 이론을 갖다가 이제 그러니까 내 생각은 그래요. 조금 이제 마음대로 사는 사람입니다. 그래도 여전히 뭐 이렇게 그 사람 이론을 보면서 리스펙트는 해요. 뭐 인간이 개차반이든 아니든. 하지만 그 정도가 안 되면 여러분 이렇게 thank하고 sorry하고 살아야 됩니다. 그거 하면 그러니까 공부도 잘하고 그리고 또 리서치도 잘하고 인간도 되고 얼마나 좋습니까? 그죠? 절대 잊지 말기를 바라고요. 그리고 참 짧은 시간이었는데 참 내 강의가 참 재미가 없었나 봐요. 굉장히 많았던 걸로 기억이 되는데 사람이 이제 점점 줄어들어가지고 이제 굉장히 그러니까 뭐 그래도 나는 그러니까 행복한 시간을 여러분들하고 가졌습니다. 왜냐하면 내 수업이 원래 한 5명, 그러니까 많아봐야 7명 이렇게 조금 이제 어렵게 가르치는 한 4명 뭐 이렇게 들었기 때문에 그런데도 불구하고 이렇게 많이 나와줘서 고맙고 혹시 environmental chemistry를 조금 더 또는 이제 environmental physical chemistry나 organic chemistry 쪽에 관심이 있으면 나중에 개발 과목을 갖다가 찾아